in the darkest hours of World War II, as the flames of defeat began to consume the Japanese Empire. A desperate and terrifying plan emerged from the shadows of military secrecy. This was not merely another aircraft design, but a weapon of unprecedented destruction that would bring the war directly to American soil in ways never before imagined. The Nakajima G10N Fugaku represented Japan's most audacious attempt to turn the tide of war through sheer terror and technological might. Picture this: a colossal bomber, larger than anything the world had ever seen, thundering across the Pacific Ocean with a payload of death destined for American cities. Yet this aircraft would never take to the skies, becoming instead one of history's most fascinating what-if scenarios. The story of the Fugaku reveals the depths of desperation that drove an entire nation to pursue the impossible, and you'll discover why this project became both Japan's greatest hope and its most crushing disappointment. The genesis of this monstrous machine began in the aftermath of Japan's devastating defeat at the Battle of Midway in June 1942. The loss of 4 aircraft carriers and hundreds of experienced pilots sent shockwaves through the Japanese high command. Admiral Isoroku Yamamoto's carefully crafted strategy of delivering a knockout blow to American naval power had failed catastrophically. Japanese military leaders realized that their initial victories in the Pacific were now meaningless against America's vast industrial capacity. The United States was producing warships and aircraft at a rate that Japan simply could not match, and the window for victory was rapidly closing. In this atmosphere of mounting desperation, a visionary aircraft manufacturer named Chikuhei Nakajima began formulating what would become one of the most ambitious military projects in human history. Nakajima, who had founded his aircraft company in December 1917, understood that conventional warfare would inevitably lead to Japan's defeat. The United States possessed industrial resources that dwarfed Japan's capabilities, and the attack on Pearl Harbor had awakened a sleeping giant that would not rest until total victory was achieved. Nakajima's revolutionary thinking led him to a terrifying conclusion. Japan's only hope lay in bringing the war directly to American soil. However, this wasn't just about bombing military targets. It was about striking at the very heart of American industrial production and civilian morale. The psychological impact of Japanese bombers appearing over American cities would be devastating, potentially forcing the United States to divert massive resources from offensive operations to homeland defense. The project that emerged from this desperate strategic thinking was initially known as Project Z, a name that would become synonymous with Japan's most secret and ambitious military undertaking. In 1942, Nakajima first presented his radical concept to the Imperial Japanese Army and Imperial Japanese Navy, but both services initially dismissed his proposals as technically impossible and strategically unsound. The sheer scale of what Nakajima was proposing seemed beyond the realm of possibility, even for a nation that had already achieved the seemingly impossible with the Pearl Harbor attack. Undeterred by official rejection, Nakajima invested his company's own resources into developing the preliminary designs for what would become the Fugaku. Throughout the remainder of 1942 and into early 1943, Nakajima's engineers worked in secret, refining their calculations and addressing the enormous technical challenges that such an aircraft would present. The project demanded solutions to problems that had never been encountered in aviation history, from engine power requirements to structural integrity across transcontinental distances. The breakthrough came in January 1943, when Nakajima established a dedicated design and manufacturing facility in Mitaka, Tokyo. This facility would become the nerve center for one of the most complex engineering projects ever attempted. The timing was crucial, as Japan's military situation was deteriorating rapidly. The Guadalcanal campaign had ended in defeat, and American forces were beginning their relentless advance across the Pacific. The need for a game-changing weapon had never been more urgent. By April, 1943, Nakajima had assembled comprehensive technical studies and feasibility reports that demonstrated the project's potential. When he again approached the Imperial Japanese Army and Imperial Japanese Navy, the military situation had changed dramatically. Both services now recognized that conventional strategies were failing and radical solutions were needed. Yet even as they expressed interest, fundamental disagreements emerged between the two branches of the military. The Imperial Japanese Army envisioned the Fugaku as a high-altitude bomber capable of operating at 32,800 feet, carrying heavy defensive armament to fight its way through the American interceptors. In contrast, the Imperial Japanese Navy wanted an aircraft that could fly at the stratospheric altitude of 49,200 feet, where American fighters and anti-aircraft guns would be ineffective. This fundamental disagreement would plague the project throughout its development as engineers struggled to meet conflicting requirements. The aircraft that emerged from these competing visions was truly monstrous in scope. The Fugaku was designed with a wingspan of 213 feet and a length of 147 feet, making it substantially larger than the American B-29 Superfortress. However, size was just the beginning of the aircraft's extraordinary specifications. The Fugaku would be powered by 6 massive engines, arranged in a configuration that had never been attempted on such a scale. The original engine design called for 6 Nakajima HA54 engines, each producing an unprecedented 5,000 horsepower. These were not conventional aircraft engines, but rather revolutionary 36-cylinder radial monsters that were essentially 2 HA44 engines joined together. Each engine would drive contra-rotating propellers with a diameter of 14 feet 7 inches, creating a thunderous roar that could be heard for miles. The total power output of 25,000 horsepower would be sufficient to propel the massive aircraft to a maximum speed of 422 miles per hour at 32,800 feet. Yet the Fugaku's true terror lay not in its size or speed, but in its versatility and range. The aircraft was designed with 3 distinct mission profiles, each more frightening than the last. The primary bomber variant would carry 44,000 pounds of bombs across a range of 11,000 miles, enabling it to strike targets throughout the American mainland. The flight plan was breathtakingly audacious. Take off from the Kuril Islands, bomb American industrial centers, then continue across the Atlantic Ocean to land in Nazi-occupied Europe. The strategic implications of this capability were staggering. Japanese bombers could strike at Boeing's production facilities in Seattle, Ford's Willow Run plant in Detroit, or the massive shipyards of Newport News. The psychological impact would be equally devastating, as Americans would realize that their homeland was no longer safe from enemy attack. The Fugaku would transform the Pacific War from a distant conflict into a direct threat to American families and communities. But the bomber variant was only the beginning of the Fugaku's terrifying potential. The transport version was designed to carry 300 fully equipped troops across the Pacific, enabling Japan to launch actual invasions of American territory. The target was specifically identified as the Seattle-Tacoma area, where Japanese forces would seize the airport and then advance overland to destroy Boeing's B-29 production facilities. This scenario represented Japan's ultimate gamble, a direct assault on American soil that would either force a negotiated peace or trigger the complete destruction of the Japanese Empire. The third variant of the Fugaku was perhaps the most horrifying, a gunship armed with 40 downward-firing machine guns arranged in the fuselage. This flying fortress of death would rain bullets at a rate of 640 rounds per second, creating a devastating wall of fire that could sweep enemy ships or ground formations from existence. The tactical concept called for multiple Fugaku gunships to attack in formation, creating overlapping fields of fire that would be impossible to survive. The engineering challenges facing the Fugaku project were beyond anything previously attempted in aviation history. The HA-54 engines required revolutionary cooling systems to prevent overheating, while the aircraft's massive size demanded new approaches to structural design and materials science. The fuel capacity alone was staggering, requiring tanks that could hold enough aviation gasoline to sustain flight across 11,000 miles while carrying a full combat load. As 1943 progressed, the reality of these challenges became increasingly apparent. The HA-54 engines proved to be a nightmare of complexity, with cooling problems that defied solution. The 36-cylinder configuration generated so much heat that conventional cooling methods were inadequate, yet the engines were essential to achieving the performance requirements. Nakajima's engineers worked frantically to develop new cooling technologies, but the problems seemed insurmountable. The material shortages that plagued wartime Japan compounded these technical difficulties. The Fugaku required massive quantities of aluminum, steel, and other strategic materials that were already in desperately short supply. The project competed directly with fighter aircraft production at a time when Japan faced increasing pressure from American bombing raids. Every ton of aluminum allocated to the Fugaku meant fewer fighters to defend Japanese cities and industrial centers. By late 1943, the project had attracted the attention of competing aircraft manufacturers. Kawasaki began developing their own ultra-long-range bomber, designated the K-191, which would serve as a backup to the Fugaku. This four-engine design was more conventional than the Fugaku, but still represented a massive undertaking. The K-191 would be powered by 4 Mitsubishi HA-214RU engines, each producing 2,500 horsepower, and would carry 12 20mm cannons for defensive purposes. The Kawasaki design offered some advantages over the Fugaku, including a pressurized cabin and more manageable engineering challenges. However, it also faced the same fundamental problems: inadequate engine technology, material shortages, and the increasing pressure of American bombing raids. Work on the K-191 began in May 1943, and by the end of 1944, a prototype was under construction, along with the tooling needed for full-scale production. Meanwhile, the Fugaku project continued to struggle with its engine problems. The decision was made to abandon the problematic HA-54 engines in favor of the more reliable K-11A engines, each producing 2,500 horsepower. While this change made the aircraft more feasible from an engineering standpoint, it also severely compromised its performance. The reduced power output meant that the Fugaku would be slower, carry less payload, and have reduced range compared to the original specifications. The modification to use NK-11A engines represented a fundamental shift in the project's goals. The aircraft could no longer achieve the transcontinental range that had been its primary advantage, making it little more than a conventional long-range bomber. The dreams of bombing American cities and landing in Nazi-occupied Europe were replaced by more modest objectives that other aircraft could potentially achieve. As 1944 dawned, the strategic situation facing Japan became increasingly desperate. American forces had launched their Central Pacific offensive, capturing the Marshall Islands and advancing toward the Marianas. The loss of Saipan in July 1944 would bring American B-29 bombers within range of the Japanese home islands, fundamentally altering the strategic balance of the war. The fall of Saipan marked the beginning of the end for the Fugaku project. With American bombers now capable of striking Japanese industrial centers directly, the need for defensive fighters became paramount. Resources that had been allocated to the Fugaku were redirected toward interceptor aircraft development as Japan shifted from offensive to defensive strategies. The project was officially canceled in July 1944, and the specially constructed facility in Mitaka was abandoned. The cancellation of the Fugaku represented more than just the end of a single aircraft project. It marked the collapse of Japan's last hope for achieving strategic parity with the United States. The decision to abandon the project was made by the same military leaders who had initially embraced it. But the changing realities of war left them with no choice. Japan's industrial capacity was simply inadequate to support such an ambitious undertaking, while simultaneously meeting the immediate needs of homeland defense. The Kawasaki K10N. One project suffered a similar fate, but through different circumstances. While work continued into 1945, the increasing intensity of American bombing raids made progress increasingly difficult. In February 1945, a B-29 raid destroyed the tooling and production facilities for the KY-91, effectively ending the project. The prototype that had been under construction was never completed, and all related documentation was lost in the bombing. The human cost of these failed projects extended far beyond the resources invested in their development. The engineers, technicians, and workers who had dedicated themselves to the Fugaku and K191 projects saw their efforts reduced to nothing as the war turned against Japan. Many of these individuals would later find new purpose in Japan's post-war reconstruction, bringing their advanced engineering skills to the emerging automotive industry. The technical innovations developed for the Fugaku project would eventually find application in civilian industries, though not in the ways originally intended. The engine cooling technologies, structural design principles, and manufacturing techniques developed for the aircraft would contribute to Japan's post-war industrial recovery. Many of the engineers who had worked on the project would later join companies like Nakajima's successor, which would eventually become part of Subaru. The legacy of the Fugaku extends beyond its immediate technical contributions to encompass broader questions about the nature of warfare and technological development under extreme pressure. The project represents both the incredible ingenuity of Japanese engineers and the fundamental impossibility of overcoming strategic disadvantages through technological solutions alone. No matter how advanced the Fugaku might have been, it could not have compensated for Japan's lack of industrial capacity and natural resources. The story of the Fugaku also illustrates the role of desperation in driving technological innovation. The project emerged from a recognition that conventional approaches to warfare were failing, and that only radical solutions could potentially change the outcome. However, the same desperation that drove innovation also led to unrealistic expectations and the misallocation of scarce resources. The Fugaku consumed materials and engineering talent that might have been better used in other applications. The comparison with Nazi Germany's America Bomber project reveals interesting parallels and differences between the two programs. Both emerged from similar strategic situations, with Axis powers recognizing the need to strike at enemy industrial capacity and civilian morale. Both projects pushed the boundaries of contemporary technology and required unprecedented engineering solutions, yet both ultimately failed due to similar problems: inadequate resources, competing priorities, and the fundamental impossibility of achieving strategic objectives through single weapon systems. The Fugaku project also demonstrates the importance of realistic assessment in military planning. The initial enthusiasm for the project reflected a failure to adequately consider the technical challenges and resource requirements involved. The assumption that Japanese engineers could solve unprecedented problems with limited resources proved to be overly optimistic. The project's cancellation represented a belated recognition of these realities, but only after valuable resources had been expended. The aircraft that was meant to bring terror to American cities instead became a symbol of Japan's inability to match American industrial might. The Fugaku's failure highlighted the fundamental asymmetry in the Pacific War, where American factories could produce thousands of conventional bombers, while Japan struggled to complete a single example of its super bomber. The project's cancellation marked the end of Japan's offensive ambitions and the beginning of its final defensive phase. The technical specifications of the Fugaku remain impressive even by modern standards. An aircraft with a wingspan of 213 feet, powered by 6 engines, producing a total of 15,000 horsepower, would be considered remarkable in any era. The planned payload of 44,000 pounds exceeded that of most contemporary bombers, while the range of 11,000 miles was unprecedented for aircraft of that period. These specifications demonstrate the ambitious nature of the project and the advanced thinking of its designers. However, the gap between theoretical specifications and practical achievement proved insurmountable. The engine problems that plagued the project were not merely technical difficulties, but fundamental barriers to the aircraft's completion. The cooling challenges associated with the HA-54 engines could not be solved with available technology and materials. The decision to switch to less powerful engines effectively ended the project's viability, as the reduced performance made the aircraft unnecessary. The Fugaku's story serves as a cautionary tale about the limits of technological solutions to strategic problems. While the aircraft might have been capable of bombing American cities, it could not have changed the fundamental balance of industrial capacity between Japan and the United States. The psychological impact of such attacks would have been significant, but the material damage would have been insufficient to alter the war's outcome. The resources invested in the Fugaku might have been better used in other applications that could have extended Japan's ability to resist American advances. The project's cancellation in July 1944 coincided with the beginning of the American strategic bombing campaign against Japan. The B-29 raids that began in earnest following the capture of Saipan demonstrated the effectiveness of conventional strategic bombing using proven aircraft technology. The Americans achieved their strategic objectives through the mass production of reliable bombers, rather than the development of revolutionary new designs. This contrast highlighted the fundamental differences in approach between the two nations and the advantages of American industrial methods. The engineers who worked on the Fugaku project represented some of Japan's most talented technical personnel, yet their efforts were ultimately fruitless due to circumstances beyond their control. The project's failure was not due to lack of skill or dedication, but rather to the impossibility of achieving unrealistic objectives with inadequate resources. The same engineers who could not complete the Fugaku would later contribute to Japan's post-war economic miracle, demonstrating that the problem lay not with individual capabilities, but with wartime constraints. The story of the Fugaku remains relevant today as a study in the relationship between technological ambition and practical limitations. The project demonstrates how desperate circumstances can drive innovation while simultaneously creating unrealistic expectations. The balance between pushing technological boundaries and accepting practical constraints remains a crucial consideration in any major engineering undertaking. The Fugaku's failure serves as a reminder that even the most advanced technology cannot overcome fundamental strategic disadvantages or resource limitations. The aircraft that was meant to terrorize American cities instead became a footnote in aviation history, remembered more for what it represented than for what it achieved. The Fugaku embodied Japan's final attempt to achieve strategic parity through technological superiority, but its failure marked the end of such ambitions. The project's cancellation represented a turning point in Japan's war effort, as the nation shifted from offensive to defensive strategies and began preparing for the inevitable American invasion of the home islands.